That was an incredible introduction. I'm so happy to be here. That loop was amazing. Cam and I were excitedly waving. So, hello, good morning, good afternoon, good evening, and good day to everyone watching live around the world. Please leave a comment and let us know where you're watching from. Say hi. But I'd like to welcome you to Let's Learn Live. Write your first code using C Sharp. I am David Pine. I'm going to be one of the hosts today.
David,
I'm joined by, yeah.
where are you streaming from?
I'm streaming from Wisconsin in the US. What about you, Cam?
I'm streaming from Kansas City, Missouri, also in the US, home of good barbecue and the
I,
Chiefs.
I did want to say that I just wanted to thank our production team who explicitly forewarned us that there's going to be a stinger video and that we will be live and not to look like deer in headlights. Ironically, that's what happened when we were trying to play the stinger video. So
The magic
we're
of live
live.
streaming.
We're live. Awesome. So I think we should just jump right into it right away. So today we're going to be teaching you and walking you through some training material that's available free of charge around the globe. In fact, it's already up on Free Code Camp as well, but we're going to be using the Learn platform. And we have a link that we'll share with you. And then Cam is going to share his screen, and you can follow along in your own browser if you'd like, but there are no formal prerequisites. All you need is internet access and a browser. You don't need to install anything besides the browser that you choose to use. And we'll be running some code in the browser and writing code and things of that nature. So let's get to it.
Let's go ahead and put my screen up, please.
We are totally live.
Oh, am I not? I was sharing it. Did it stop sharing? Again, the magic of live streaming.
Yeah. We are totally live. We got this. All right.
In our to our credit, this is a little earlier than we usually stream.
Yeah, a couple hours. Cool. Awesome. So this is the write your first code using C Sharp. Get started with C Sharp part 1. This is a learning path, and learning paths on our Learn platform are comprised of individual learning modules. So it's a collection of modules. We're going to go through 4 of them, pretty rapid succession, and then we'll go through the guided project, which is the 5th module, and we'll leave the 6th module for you, the viewer, to do on your own. But as we go through this, the idea is that you've never touched C Sharp before, or you're very, very new to it, or you're even new to just programming in general. So this is going to be really your launch pad to help you accelerate learning, and we're going to be your guides. So I'm super looking forward to it. And the first one we're going to start off with is write your first code. All right, so we've got some learning objectives. What we're going to do is we're going to write the very first lines of C Sharp code you've ever written. You're going to use 2 different techniques to print messages to a text console. We're going to look at some various issues and things that might go wrong, why that would happen. And we're going to talk through some of like the syntactual elements like operators and classes and methods, just from a high level view. So there's going to be lots of text, and we're not going to read that for you. We'll summarize it at like a high level. But C Sharp, it's a programming language, and it's part of the .NET ecosystem. So Cam and I are .NET developers, and for me, C Sharp has always been something that I really love working with. The programming language itself, I would argue, is modern, even though it's been around for a very long time. It continues to innovate. It's developed in the open. Features of the language itself are influenced by the community and championed by various community members and implemented by community members sometimes as well. So you can use C Sharp essentially anywhere. I mean, basically anywhere that you want to write an application, you can use C Sharp as the programming language.
And to really emphasize that, there's a lot of misconception around C# and .NET, right? There are a lot of folks still think that .NET is just Windows only, right? But the modern incarnations of .NET have been Windows only for several years. So if you are programming for Linux environments or IoT or whatever,
Mac, anything, iOS.
yep,
Yep,
we've got
absolutely.
you with C#.
All right, so let's just go to the actual first exercise. So now in unit 2 of this is where we actually start writing code. So you'll notice on the left, Cam's window is describing something to do, and on the right is an actual .NET editor built into the browser. So Cam is typing console.writeLine. He's got open and close parentheses, and then inside there he's got double quotes, hello world, exclamation mark, and then a semicolon. So this that he's writing, this is actually the code on the right, and this is various syntactical elements. So console is an object. It's part of the system namespace. And we don't necessarily have to get into namespaces or things like that, but think of console as an object. And the console lets us walk up to it. And when you say dot, that dot notation lets us evaluate various properties or methods that are part of that object. So console has a method called writeLine. And as you can imagine, writeLine will write a line to the console. So given the arguments, which is this string literal of hello world. So now once we run this.
Well, and one other important part of the anatomy of a line of C# code is this right here.
Yes. So the semicolon is the terminator. And this basically says that this expression, this line of code is kind of finalized, right? Without it, yeah, go ahead and run it. So it says hello world. That's the output. So hello world is a canonical example. It's used all over in different programming languages as well. So with a single line of code here, we're able to write our first C# code ever. Hey, it's pretty cool. But there's various things that might go wrong. So since it is a text editor, let me know in chat if ever you've been typing a message like a DM or something like that, and you've sent it and it had a typo, right? I can imagine that that's probably been the case. The same is true with text editors for code. So it's very possible that you'll have a typo. And if you do, you'll notice that there's a red squiggle. So this is kind of like spell check. But essentially what this is it's the C# compiler letting us know that there's a compilation error that there will be if you try to run it. So if you hover over this red squiggle, yeah.
And this red squiggle is kind of a convention that you see in a lot of what we call IDEs, integrated development environments. Basically special text editors just for programming.
Yep. They're kind of powered by like language features and the compiler and all these different things that help kind of infer your intent from the text you're writing. In this case, it's saying console with the lowercase. It doesn't exist in the current context. So that's not going to be able to run. If you run, it's going to result in a compilation error. And it's telling us that at line 1, character 1, and there's a specific error number, CS, which stands for C# 0103. So if you're actually to look that CS 0103 up in a browser, it will bring you to a page in our learning platform that explains that error wholeheartedly and kind of talks to how to potentially fix it. So in this case, you just have to fix the case in console with a capital, and then it will work. So let's update this to the next example where things might go wrong. And in C#, when you want to have a string literal, it's a double quote. In this case, it's saying to use single quotes just to kind of exemplify the error or the experience. So the problem with having console.writeLine with single quotes is that single quotes indicate that you're going to then have a character literal. And characters do not have, or like a single character is not more than 1 in length. So this right here is, hello world, and that's a lot more than a single character, right? So it says too many characters in character literal. So again, if you're going to represent a character, let's actually do this real quick. Delete everything except for the leading H. And that will work because that's a single character. But all we're going to write then is the single H to the council, right? So, but if you have anything more in there, any more character literals inside your character expression, it won't work. That's where you have double quotes to make it a string, right? So there's a difference between strings and characters. So let's go back to the string literal. And it says this one wants us to display a new message. It wants us to comment this out. So in C#, there's many different ways that you can comment code out. In this case, you can use 2 forward slashes, and then notice how the text will actually turn green. And that indicates that this is a console. In that single line, you could literally put anything else that you want. And that's going to be, that's going to be treated as a comment, right? So this console.writeLine code won't actually do anything. If you run it, you'll just have no output because it's just a comment, right? So there's various APIs that exist. API stands for Application Programming Interface. So on the console object, we were looking at write line, which will write a single whatever it's given and then a line after it. We could also write console.write. Any guesses what that might do, Cam?
Well, since the other method was write line and this one is just write, I'm going to guess that this just writes out to the console without creating a new line, that it just writes on the existing line and then stops.
That's a really good guess. So we say console.write, congratulations. And then on a new line, there's another line of code, line 4. It says console.write, and then there's a space. And then after that, line 5 says console.write. You wrote your first lines of code. So let's go ahead and run this. And as you imagined, Cam, you're correct. Congratulations. You wrote your first lines of code. Hooray! And it was in C#, so that's awesome. But again, these are pretty straightforward examples. And I would love if you're watching live, if you ask questions. We can, we're happy to be interjected here at any point in time and happy to field questions as we're going through this. So if something doesn't make sense, this is for you and for your benefit, and no question is a bad question. All right, so we kind of talked briefly about compilation and syntax, programming languages, things like that. So this says, what is a programming language? C# is a programming language. It's not dissimilar to JavaScript. It's one of the world's most popular programming languages in the world, or Python, or Java, or C++, or these other languages that you may have heard of. C# is a programming language. And essentially what it lets you do is you write code, and you have in this case, a compiler. It compiles your code down to machine IL, like intermediate language, and the machines know how to take those instructions and execute them.
So the C# code is really just for us developers, right? It's for us to be able to conceptualize what we want to tell the computer to do. And then once we write the code, we run it through a compiler that converts that to machine code that the machine can understand.
Absolutely. So then what is compilation? Compilation is, it's a mechanism for taking that code, the stuff that the developer intends to be representative of a set of instructions for the machine, and it converts it into the code that, or the byte code essentially, that the machines can understand. So the compiler is your friend in that it takes your intent and makes it into, in this case, an executable.
So David, I have a question for you. Why then didn't I need to compile the code here in my browser?
That's a good question. So in this case, we're using try.net. It's a .NET editor in the browser. So essentially the way this works is it takes your code, your raw text here, and it sends it to a server somewhere that takes the code, compiles it on that server, runs the code, takes the output, and then sends the output back as a response to your browser to print out and show you what happened.
Oh, okay. So when I click this run button here in the browser, it would be like if I was in an IDE on my machine and compiled it and ran it, but it's compiling and running on the server and sending me the results in this browser.
Absolutely.
Got it.
100%. Yep. Yep. And then, so what is syntax? Syntax is the various ways that we represent our intent in code. So when you are writing our C# code here, we're using various syntax to express our intent, right? So does that make sense? Is that pretty straightforward?
Yeah, I think I think that I think we've covered it.
Awesome.
Oh.
The other thing, yeah, understand the flow of execution. So that's another thing that's very important in programming with C# specifically. Our code isn't executed arbitrarily. Instead, it follows a very specific flow of execution. So line 3, well, actually, in this case, line 1 is the first thing to be evaluated. It's a comment, so it doesn't have to do anything. Line 2 is then evaluated. It's an empty space. Again, no operation needs to take place. Line 3 is evaluated. It walks up to the console object. It's in the context of the execution of this program. So the console object's there, and then we call .write, given some arguments, the congratulations. So it will then say, write congratulations to the console. Then the next line executes, which is the line 4, writing of a blank space. That's how we get the space in our output on the bottom. And then line 5, console.write, you wrote your first lines of code. So it follows a very specific order. So let's do a knowledge check in the browser here. And I'm going to actually call on, how about with the first one here, we have Cam try to answer it. And then maybe the next ones will get more advantageous and see if we can have our viewers answer. Or if you're watching, do you think the answer is A, B, or C? So the question is, what is the difference between console.write and console.writeLine? Option A is console.write prints the output on a new line. Option B is console.writeLine prints the output on a new line. Option C is console.writeLine appends a new line after the output.
Well, we have a response. We have at least one person on YouTube saying that it's C.
Several C's and then one B. So let's do C. We got 3 C's so far. Let's check the answer. Ta-da! Correct. It was answer 3.
Now I'm in my guest browser here for the purpose of this. For the purpose of this presentation. So I'm just going to continue without saving. But if you are doing this at home and you are logged into Microsoft Learn with your Microsoft account, you can save your progress, which is useful for when you want to come back and finish later on.
Absolutely. So there's a challenge. Go ahead.
Yeah, we have a code challenge to do. They want us to just like write the code in the .NET editor to display 2 messages. We want to display this is the first line and this is the second line. So what do you think, David? There's like a bunch of ways we could do this.
Yeah. So yeah, there are lots of ways that you can do this. You are correct that you would want to use the console object again. That is how we are going to write to the console. There are 2 lines though, however, so you could do it many different ways. I'm curious to see what approach you're going to take. So it appears as though Cam is going with multiple writes, not writing a line yet, and he's got a space before each of the new words. So if he used to run this at this point, that would end up with, this is the first line. And this is the second line. And I know what's going to happen here. I already see the I already see.
I caught it. I caught it. I caught it.
Let's go ahead and run it though, and see if we get the output that we are expecting. So this says council.write this, write is, write the, write first, write line, and then a write line on line 6. So does anyone know why this isn't formatted the way we are expecting it here? In question number 2, write the code that produces the following output.
Well, I am gonna guess that it has something to do with the difference between write and write line.
Mm-hmm. Yeah, you're correct. So if you just add write line there, and then run that, that will give us the output that we're expecting. Awesome. So you've done it. And there are multiple ways that you could have done this. Instead of doing multiple writes, you could have done all of that in a single write line and then everything else in the next write line. And that would have worked also. Yep. Perfect.
Wait. We're gonna try another one.
Okay.
This one isn't advanced. This one is not covered in the material. You don't have to do this at home. I'm gonna.
Yeah. So, or you can just do N. You don't even need the R.
Don't even need the R.
Nope. All right. So what is this doing? So council.write line, everything within inside the quotes is a string literal. Now, once it gets to the \n, that's an escape character saying, I'm going to treat this next character as a sequence. So this is an entire escape sequence saying new line. So \n in Linux operating or Unix operating systems is what's used for new lines. In Windows, it was as Cam had it before, \r\n. They'll both work and do the exact same thing. They just end up having a different set of returns at the end. So if you're to run it, it ends up being the exact same result.
So sure enough,
yeah.
The solution, somebody took one of the solutions took an approach kind of like what I took originally. And
I'd love
lots of different ways to solve that.
I'd love for people to share on any of the comment sections on how they were able to achieve their, if they achieved the challenge, how they did it and how it worked out. So are we doing knowledge checks here too?
Yeah, let's do it.
All right. So question number 1, what is the primary job of the compiler? So option A is the compiler primarily locates spelling mistakes in your code. Option number 2, the compiler primarily executes your code. Option number 3, the compiler primarily converts your code into an executable format that the computer can understand.
Well, let me talk through this. So the compiler, so the first choice says the compiler primarily locates spelling mistakes in your code. Well, I know that when we were typing things wrong earlier, I got the red squiggles in my IDE. And the compiler, I think, contributed to that, but that's not its main purpose, right?
Right.
Okay. And then the compiler primarily executes your code. No, that's not true. We covered that. The compiler doesn't execute the code. The code executes more like lower level, closer to the machine, right? The machine language. So that's not it. So it must be 3. It must be it converts the code into an executable format that the computer can understand.
Okay. So then which of the following statements is true about C#? C# is case insensitive.
No, I don't think that's it. That bit us earlier when I did the lowercase c console.
And then option number 2, counsel is a method and write line is a class.
I think that might be backwards. I think console is the class and write line is the method.
And then option number 3, you use double quotation marks to create a literal string.
That's right. That is true.
Yes. Okay. What is wrong with this line of code? Console.writeLine. What is wrong with me?
Ooh, let's leave this one for the audience.
All right.
Here, I'm gonna zoom in so it's easier to see.
Yep. So it says option number 1, the L in WriteLine should be lowercase. Option number 2, it's missing a semicolon at the end. And option number 3, the string should use single quotes. Everyone is saying B, 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 B. And we do have some questions coming in. I'm going to try to answer these actually while we're doing that. So you're going to hit check answers. And there was a question. People are asking, what's the difference between \r and \n? It's not really covered in the material here, but those are various ways that you can do string, like new lines in a string, literal. So \r is carriage return. Like imagine typewriters, the carriage would physically return, like that's essentially what that meant. So in the context of text, it's the same type of thing. Whereas \n stands for new line. In Windows, it's the combination of those two. And on Unix, it's just new line. And actually, I think some other operating systems will actually do just carriage return. So any combination, I typically normalize around \n. And then we've got another question here. What is a class? That is something we failed to talk about before. So I'm happy to address that right away. A class in object-oriented programming, specifically in C# is essentially the constructs of an object. It's like the shape of an object. So console it's actually a static class. So we don't need to get into static and stuff like that. It's a little bit beyond the scope of what we're trying to teach here. But imagine that we have a person that we want to represent. Our class, we could call person, would have various members on that person that represent a person. So like a name, property, and an age property, or a date of birth property. And then you might have methods. So a person can do certain things. So you would express those functionalities through methods. So that's a class, and an instance of a class is like an object. So we can talk more about that too as we get further into some of these lessons.
Another, I'm just to add a little color on that, and again to emphasize, we haven't really gotten to object oriented yet. We're just talking individual lines of code executed in a top to bottom fashion, right? We're not getting crazy with object oriented yet. But to add a little more color to his explanation, you can think of a class as like if you're building a house, right? And I like to think of like the class as the blueprint for the things the house should have, and then the actual physical house as the object.
Absolutely. That's a really good way to put it. And I do know for sure that this is the literally like the first C# bits section that we're going to be talking on, that Cam and I are doing. This is part of a larger series that they're going to just keep going deeper and deeper with C#. So be sure to check back for deeper learnings. And I'm happy that there's so many questions and engagement. So that's the first module. That actually took a little bit longer than I thought, but that's great. We'll jump on to the next one, which is storing and retrieving data using literals and variables. So in this case, we're going to talk through variables and declaring and initializing variables, and how to retrieve them and how to set them, and different types, right? We're going to get a little bit deeper into this. So don't need to read that exercise. So one of the things that we had talked through was walking up to the console, asking its write and WriteLine methods to print or output rather various combinations of things. So if we run this, this will actually just output B, the character B. And we talked about that earlier when we were showing kind of the differences between strings and characters. So this is just outputting the verbatim character B. So that's cool. If we were to change it to a double quote, that would, yeah, we already saw this before too. You run
This
that.
doesn't work.
Doesn't work. We know why. Let's talk about, instead of characters and strings, let's talk about some different data types. So let's do 1, 2, 3. So when we output this, anyone want to guess what it's going to output? 1, 2, 3. Hooray. It's not really rocket science, but go ahead, Gab.
So I noticed that there's no quotes on this, David.
Yeah. Yes, there are no quotes. There's no strings on me. So in this case, Pinocchio is free. No, it's actually an integer, so it's represented as a number. So it's a different type. It's not a character, and it's not a string. It's an int, and an int represents a number. And there's various ways that you can represent numbers in C#.
So what I'm hearing then is that these two values, 1, 2, 3 in quotes, is not the same as 1, 2, 3 without quotes.
Correct. So these are strongly typed, and in C#, the compiler uses the type system to evaluate your intent. So the line 3 is representing 1, 2, 3 as a string literal, and line number 4 as a numeric literal for the value 123. So there's different precisions. So yeah, you can do both of those, and if you print both of them, they print the same thing because output, that's what they're going to look like. You could change that to put more like single quotes around your literal of 1, 2, 3, so that in the output it would kind of differentiate it. But that's not necessary. Yeah. Oh no. Yeah. Okay. All right. So, what else can we put to output? So there's floating points. So we start getting into fractions and decimals and things like that, and that's where singles and doubles and things like that come into and decimal too. Yeah. So the float type has roughly 6 to 9 digits of precision, whereas the double has 15 to 17 digits, and decimal has 28 to 29 digits,
So David, why do you think that is? Why do I need to so you're saying I need to specify if I'm using a number that's not an integer, if I'm using a number that has a decimal point and additional digits, why do I need to think about what kind of numeric type I'm using here? What's the difference?
So it all has to do with how we want to evaluate various mathematical operations. So, and at a lower level, there's different ways that we can represent numbers. We can do even smaller than float and int, and there's shorts and bytes and things like that. But it all has to do with how precise we want to be with what it is that we're trying to express. So you might imagine like a banking system that's written in C#. You would want to ensure that you're using the most precise calculations. Whereas if you're calculating like an average of a GPA or something like that, it may not need that much precision.
So the F is what my 0.25, the F is what makes that a float then.
Yep. And it's valid. You can use a lowercase f or an uppercase f. Those are essentially the same thing. But what you're doing is you're saying console.writeline 0.25 f. So it's going to be treated as a float. Ironically, it's already a float at that point because that's the default for anything with a decimal. If you were to change it to an M, for example, it would write it as output's the same, but it actually treats that then as a decimal rather than a float type.
Why wouldn't I use D?
Because that's not the specifier.
Right.
I don't actually know. I don't remember offhand why D isn't the specifier.
All right. So let's check out the next one. 625. That's what is this here? This is where there's no character afterwards. So this is just what a decimal.
Yeah, 2.625 to create a double literal. Just enter that, and the output's there. Yep. Oh, and this one shows how to do like M, which is for decimal, the literal suffix. All right, so what we're doing here is we're literally just outputting various numerical types. And we went through int, and we did float, and we did double, and we did now decimal. But there's many other types, and these are just the built-in like primitive types. So we can do Boolean, either true or false. So if we write true and false, it will output the capitalized string literal versions of those two.
Okay, so I guess we kind of covered this earlier, though, that these types, you mentioned the term strongly typed. So
Yep.
when we have a variable that we're going to store information in, I guess each one of those variables has one of these strong types associated with it.
Yes. Yeah. So we haven't even jumped into literals and things like that, but these are different. To recap, these are different types that we're passing into. Write line actually accepts object, which is like anything in C#. So we can use string for words and phrases, and those can be represented as a literal, like string literal. We can use characters for single alphanumeric characters. We can use int for whole numbers, decimals for a number with a fractional component, and bool, which is just short for Boolean, for true or false values.
Cool. All right, so now we move from literals to variables.
Yeah, so what we were doing before was walking up to the console, exercising a method, and passing in an argument. Now with variables, things are going to be a little bit different because we're going to declare a variable. So in this case, it says string first name, semicolon. And then if you run this, what do you think will happen? There's no output because we're not outputting anything, which is, I guess, expected, right? So what we're doing is we're declaring this first name variable. So the name of the variable is first name, and its type is string. So we're saying that this has to be a string. And there's lots of different naming conventions and different ways to do it. My recommendation is holistically to always follow what you believe to be the best approach with naming. Most projects that you get into, if you're collaborating in like an open source environment, people will already have kind of their styling and things like that available that they recommend. So recapping, variables are temporary values that you store in a computer's memory. Before you can use a variable, you have to declare it. So in other words, like when we said string first name, any lines that followed that or any lines before that could not reference first name because it wasn't yet declared. To declare a variable, you first select the data type of the kind of data you want to store it in, and then you give it a name. So it's pretty straightforward. So we could have done any type. There could have been like bool or int or decimal and then various things for it. So let's do a variable assignment. So we're going to say first name equals Ada or David. So what we're doing here is we're saying on line 1, we have a variable declaration, which is going to be string of string type, first name. And then on the next line, we're saying first name equals the assignment of the string literal David. So the first name variable on line 3, if we were to access it, would be what? It would be David. So there's different ways to look at this. So like it's saying here, assigning a value is referred to as setting the value. What if we were to do it the wrong way? So the wrong way is don't do it this way because this doesn't work. So what this does is it results in a compilation error. So it's saying the left-hand side of an assignment must be a variable property, or indexer. And it's saying use of unassigned local variable first name. So this is, go ahead.
Yeah, I was going to say, so there's actually 2 errors then.
Yep. So on the left-hand side of the equals, that has to be a variable, a property, or an indexer.
Can't be a literal.
Can't be a literal, right?
Okay.
And then it says that we were using first name on the right-hand side before it was assigned, because it was unassigned at that point. So let's put that back the way it was. There we go. Everything's happy now.
Still works, but no output.
Right. So now if we want to retrieve the value of it, we just ask for it. So we can say council.writeLine and then give it the first name.
So no quotes, because we're giving it the variable. The variable contains the string, which is denoted by the quotes.
Mm-hmm.
Got it.
Exactly. So string first name is declared, then it's assigned the value of David, and then we call councils.writeLine given the variable. So we're going to access that variable. So temporarily, here's what's happening. We're declaring a variable in memory, and then we're assigning a variable, a value to the variable. We're setting it. And then in line 3, we're asking for the value of that variable in memory. So essentially what we're doing is we're saying, here's this variable that we have. We're going to put a value in it. And later on, during the execution of our application, this could be at any point later, we're going to ask for the value of that variable, and we're going to do something with it. So we're going to mod. Go ahead.
So let's take this next exercise then. I'm just going to paste in the code they give us. Tell me what's going on here, David.
Yeah, so this is essentially reassignment of variables. So line 1 does the same thing we did before. We're going to declare a variable string given the first name. And then on line 2, we're going to assign it to Bob. And then we're going to write out the variable value, asking for it. And then line 4 is going to reassign it to a new value. And then we're going to write it out. And then line 6 does the same thing, just changing the name each time. So essentially what we're doing is we're saying we've got a variable named first name. We're going to put a value in it. And then we're going to ask for the value and print it out. And then we're going to keep changing the value over each execution here and asking for the new value. And as you can see, the output is what we would expect.
Awesome.
All right. What else we got here?
All right. So set the variable before we get it. We already did all that. What are we doing here? So, oh, look. So they're showing us a new way that we can both declare the variable and assign the value on the same line.
Yeah. Yes.
So
this technique is actually called initializing the variable, because when we declare it at the same time we're declaring it, we're also assigning to it. So this is, instead of being, multiple lines like we had before, instead of being 3 lines, we're just doing it as a single line. So we've got the variable declared as string, got the first name for it. We're saying the value is Bob. And then we're going to write that variable value out to the council, and it's going to say Bob.
So I'm kind of getting the feeling, David, that there's like a million different ways to do everything.
There is. Yeah, that's the joy of programming. And along those same lines, there's many different opinions about the correct way. All right, so let's recap. So we talked about assigning and setting a variable before it's used, before we try to retrieve a value that would get it, from the variable. We talked about how you can initialize a variable by assigning the value of the variable at the time it's being declared. We talked about assignment. It happens from left to right, where the left-hand side is the variable, equals, meaning assignment, then the value on the right-hand side. So that's how it happens. And then you use single equals to do assignments. Oh, that's something we didn't really talk about. Yeah. So there's different. That's actually considered like an operator. So the equals, that's an assignment. If we wanted to check if two values were the same, we could use double equals, and we'll talk about that later on. And then to retrieve the value of the variable, we simply use its name. Let's continue on.
Okay.
So yeah,
now you're just messing with me, David. What is this var thing?
var? Yeah. So var is a very powerful keyword. And it's essentially like shorthand for you'll know the type once I assign it. So we can't say var message semicolon because there is no type associated with that. So var has to be used as part of a like conjunctive assignment or like when a thing's being initialized. So we can say var message equals hello world. And the type, yeah, go ahead.
So I'm going to guess then that this somehow implicitly looks at the literal to determine what type to make this variable.
Correct. Yeah. So based on the right hand side, it's able to infer the type. So it knows, the compiler is smart enough to know that when you say var message equals this string literal, it knows that it's a string. So the var is essentially shorthand for any type we want to have based on the assignment on the right hand side. So as the lesson continues on, it says you can't say message equals 10.703M because it can't convert a string type to a decimal type.
Got it. So when we've initialized our var, we say, okay, you're gonna know what it is once I've assigned it, and I assign it a string, and then from that moment on, it has to be a string.
Yep.
Got it.
And Cam, I'm going to have you do this solo for the next 60 seconds. I will be right back.
All right. So to recap then on what we've learned about the var keyword, I'll zoom in to make that easier for everyone to read. That var keyword is all about inference, right? So why would you want to use that? Why not just say string? Well, sometimes it's just easier to write those 3 characters and it's obvious that what's on the right of the assignment operator is a string. So we're just going to use var. I don't care what's on the what this type is. Look at the assignment, figure it out. And if it's obvious, that's a good practice. If it's not obvious, the next programmer comes along and has to update your code. They might want to change it back to a explicit data type. All right. So this unit has a challenge then to store the following values in variables: Bob 3 and 34.4, and then display it. Hello, Bob. You have 3 messages in your inbox. The temperature is 34.4 degrees Celsius. All right. So how am I going to do that? Well, I'm going to start. Know that we can do first name, string first name equals Bob. That one's easy. Then my next type, you have 3 messages in your inbox. Well, 3 doesn't have a decimal point, so we can use int for that. There's other criteria for when you can use int, but that's probably the first one to apply. So we'll say int message count equals 3. And then 34.4. That could David, what did you say that was going to default to if I just
why don't we let the compiler figure it out?
You can say let's let the compiler figure it out. I don't care. So temperature
equals 34.4.
Equals 34.4. And we'll let it figure out implicitly what 34.4 is. And then we're going to write to the console dot write. How are we going to do this? Well, there's lots of different ways. My preferred way would be to use something called string interpolation, but we haven't gotten to string interpolation yet.
You're right. Yeah, we can do string concatenation, string interpolation. We can do string template literals, or we could do
Well, here I'm just going to use the techniques we've talked about so far.
Yeah.
Hello. Console dot write, and then
First name.
First name.
Mm-hmm.
Colon. Oops, somehow I got to the top. Here we go. Console dot write. Exclamation point space. You have space. Console dot write. And then it was what I call it, message count. Right. Messages in
Your inbox.
The temperature is right. Temperature. Console.write. And then
you have to scroll over. I don't know what it's going to put.
Degrees.
Oh, degrees. Okay.
Actually, we can make this last one right line, and it'll finish the line.
There you go.
Okay. This should work, right?
Yeah. Let's run it and see what happens.
Let's run it.
Ta-da! Hello, Bob. You have 3 messages in your inbox. The temperature is 34.4 degrees Celsius. Perfect.
Cool.
Great job. So what we did here was we declared 3 variables of different types. The first is a string, first name Bob. The second is an int as message count assigned from the literal number 3. And the other one is implicitly typed as a var, temperature equals 34.4. And then we're using various techniques of console.write and write line with variable accessing, and we're outputting a message to the console.
Now, I have a feeling that some folks are out there going, oh my gosh, that is way too much code to write one line of text. And you're actually right? This is to demonstrate the concept of here are these 3 variables. We're going to use the variables in like a linear fashion and just write out to the console. In real world code, you would probably use something like, like David said, concatenation. My favorite technique is what we call string interpolation, which don't over-index on this, right? You'll get to this later on, but here's what that looks like. So, hello, name. You have count messages in your inbox. Temperature, and I'm putting this all on one line, but again, don't worry too much about this. There are techniques that you can use to split things up into multiple lines. Temperature is what do I call it? I just call it temperature. Yep.
Yeah, that's totally fine. Just output that.
I was going to use the Unicode, but that's probably not a good practice. Degrees. So
semicolon,
we have this one
semicolon.
Oh, semicolon. Thank you.
Ta-da.
Yeah, I've been doing C# for 20 years, and I still occasionally forget the semicolon. Don't feel bad if you do it. All right, so this is all just one line of code. Again, I really want to emphasize this is not covered in the material, so don't worry about it if you don't grok it. But I just want to show you there are more efficient ways to do the exact same task.
Awesome. Let's review the solution. Hey, they did a similar solution. That's amazing. I love it. Yeah, so we talked through the way that Cam did it. We talked through exactly how that was executing, the flow of the execution, the various variables, their different types, how we assign, initialize, and retrieve those different values, and we output an expected result. So that should be hopefully pretty straightforward. So let's do the knowledge check right away. Which of the following variable names should or must be avoided? So I don't think we
Well,
covered that, did we?
I don't think we covered that, but I'm gonna guess like what is obviously different among those choices
Yeah. Yep.
is the first choice. And
Mhm.
I'm gonna guess that that dollar sign is not okay for a variable
I
name.
would concur. The other two seem reasonable in terms of what's expected out of common naming practice for and conventions for variable naming. So I agree. What is the problem with this line of code? Var message semicolon. So it says
Hmm.
var isn't a data type. Use of var keyword without initializing the variable. A variable named message should always be a string.
Well, I can eliminate that last one. That one's just silly. We can name
Mhm.
variables whatever we want to name
That's true.
them. I think technically var isn't a data type. Technically, I think it's probably a keyword, but um, but ultimately, the main problem with that line of code is, like we said earlier, you have to have an assignment when you use var, right?
Yep, you have to initialize it. I
Okay.
concur. So, which of the following is the output for a console write line 3440M?
Ooh, now that's a good question because we're adding the zero.
Hmm.
So we have this literal, this 34.40 M literal. And
Hmm.
I know it's not going to print the M, right?
Right.
Because we didn't see that earlier. What I don't know, actually I do know, but I'm playing that I don't. What I don't know is whether it's going to show the zero at the end or not. What do you think, David?
I would assume B.
Okay. Well, I'm going to pick B. Let's see what happens.
Which of the following lines of code creates a variable correctly? Int x equals 12.3 m semicolon, decimal x equals 12.3 m semicolon, bool x equals a character capital false.
Right. Well, so let's look at these. So the first one here, int x equals 12.3 m. Well, we've said before that ints don't have decimals, right?
Right.
So that can't be it.
Mhm.
The next one, decimal x equals 12.3 m. That might be right. Let's come back to that one.
Mhm.
And then the last one, bool x equals single tick, capital F, lowercase a l s e, single tick, semicolon. If I remember right, those single ticks are for character literals. They're not for booleans, right?
Right.
So it's got to be the one in the middle.
All right, let's check them.
All right. So
Ta-da!
we're going to review
Hey.
answers. Oh, wait,
Oh, all
we
right.
got one wrong, David.
So using the decimal literal m or lowercase m, it will print the number that includes values after the decimal point. Interesting. So that's even the zero. That is something I did not recall, and so that's good to know. That's great. Great to know.
Indeed.
All
All
right.
right. So we talked about displaying a formatted message using a combination of literal and variable values. I think we're making some progress in learning how to code in C sharp. I think we should do another module.
Let's do it.
Hop
Moving on to the next one.
back to my learning path here. So we did write your first C sharp code. We did store and retrieve data using literal and variable values. So now we can do basic string formatting.
And just
Um,
to let everyone know, you can follow these at your own pace. We're cruising along pretty quickly. Actually, a little bit slower than we assumed initially.
yeah, I don't
But
think we're going to get through as many as we'd hoped. I think optimistically we might get through these first four.
yeah,
But hopefully, anybody who is watching us live or watching us after the fact on YouTube or anywhere else that we have this video posted, hopefully, we're getting you a pretty good jump start on getting going on this learning path. And this
absolutely.
learning path is the first step of that free Code Camp C Sharp certification, if I remember right.
Awesome. All right, let's go to perform basic string formatting in C sharp. So this is going to talk through a lot of those different things that we kind of touched on briefly, but we're going to get a little bit deeper into it. So we're going to create string data types containing tabs and new lines and other special characters. We're going to talk about Unicode characters, new strings via concatenation and interpolation. So all the things that we were trying to talk about before, we'll cover here.
Aha.
So let's see here.
So
Yes,
we did get ahead of ourselves a little bit, but
we
now we're
did.
circling back around to some of those things we talked about.
All right, so let's grab this, paste it in there real quick. So this is council.writeLine. And as you know, there's a \n, and we already talked about that. That means inside a string that will represent a new line.
So this output down here is from the first line of code. So it's hello, new line, world.
Right. And then there's many other escape sequences that could be used. One of the other ones is the \t, which is for a tab. So when you hit tab on your keyboard, it puts in, essentially, I think it's about 4 characters in space most commonly.
Be careful. You're going to start a debate on tabs.
I know. I was just going to say, let's just use spaces. Actually, if you select the output, I'm curious how many it is. If it's actually using spaces or if it's just one. Yeah, it's just one. Okay.
Yeah,
okay.
Appears to be just one.
But it represents most commonly 4 spaces equivalent. Anyways, yeah, so that's pretty cool. If we grab the next bit here, what we're trying to do is we're trying to put quotes around world. So we're trying to output hello world with world having quotes in the output itself. Now, when you run this, it's going to have some problems. It's going to say that there's syntax error, comma was expected. Also, the name world does not exist in the current context because the way this evaluates is council.writeLine, the first double quotes, hello, space, the next closing quotes. The compiler sees that as the closing of that string. So then it says hello or hello, and then just before the word world, it gets confused because it's like, well, wait, our string is terminated. What's world doing here now? That object doesn't exist in this context. So then we call this like cascading errors. So when you've got one syntax error, that's usually you want to go to the root, and then that can help fix all the other ones. So what we're going to do is we're going to use that escape, the \, again, to escape those double quotes in both places. And now that will correct it. So this says hello world, and it's going to have double quotes around the word world when it's printed to the console.
So this / double quote you're telling me is an escape, that's an escape character, like that \n \t / double quote says give me a double quote inside a string.
Absolutely.
Okay, so let's run it. Hey, look at that.
Awesome.
I like how that's like a subtle sarcasm. Hello world.
Oh, that's funny. Yeah. All right, so let's look at this other one here. Yeah, here, more fun \. So sometimes when you have strings, they may not be escaped already. So you should never trust that a string is already escaped if you're getting it from a variable or things like that. So in this case, we do have a string literal, council.writeLine, and we're on the Windows operating system because we're referring to C folder system, source repos, and we're also using \s here. Now, the problem is a string literal in C# with a single \ is saying we're going to start an escape sequence. And since S follows it, it's going to say we don't recognize that as an escape sequence. So how can we fix that? The way to do it is to have 2 \. So you're going to have another / there and another \ there.
So you're saying \ is yet another escape sequence?
Mm-hmm.
Oh,
yep.
Okay.
So that's how you display a single backspace. Yep. So it outputs what you would expect.
Cool.
What else we got here?
So I guess we can use, it talks about formatting output using these character sequences. So I guess that's where these come in really handy, is like paste this in and run it.
Yeah. So what this is doing here is it's 4 lines of code, but each of the strings have various escape sequences in them and special characters that cause different things to happen. So We've got new lines. We've got tabs for consistency to make kind of our output be a little bit more structured. So we're going to generate invoices for a customer. We're going to do that on a new line. Here's invoice, the number of invoices and what they are, and then tabs to space them out. And you can see it makes things a little bit easier to read as output.
Cool. All right. So what's a verbatim string literal?
So a verbatim string literal is when you start a string with the @ sign. So that basically says everything that follows is essentially going to be verbatimly output to the console. So when it outputs to the console, we'll have those leading spaces, and we'll also have the other spaces from the next line. So
and a new line and everything.
A new line, yeah. So the new line that is in your code when you go to line 2 is actually carried over in that string, that verbatim string literal, and that's what's going to output. So if you run this, you'll end up. Go ahead.
So the @ sign is basically a way of saying, hey, I don't want to mess with all those escape characters. Just give me whatever's inside this string.
Absolutely. So now you may have noticed like that string : \\. We don't need to escape those anymore. We don't need to have double \. In fact, if you were to do a double \, the double \ would be verbatimly output to the console when you run it again. See?
Gotcha. So what happens if I take the verbatim character off?
Then it treats all of that as a big problem.
Because
there's a new line, there's no closing quote. New line and constant. So that's the first problem, because the compiler at this point is expecting, since it's not a verbatim, it's expecting that to be a double quote within, before a new line character.
Got it. Okay.
All right, so let's do this, where we're going to format. Yeah, if you copy that. So this is essentially doing the same thing that we looked at before. If you go back to your editor,
I deleted code. I'm reading now. There, output directory.
No, the next one down.
Right, but then. I'm not sure what the.
So you're supposed to replace.
Directory. Okay, yeah. So it is after output directory. Okay, so we'll just replace that line.
Yep.
There we go.
And then if you run that.
So generating invoices for Corp. Okay, cool.
Yeah, so that formatted using several different techniques. The lines 1 through 4 used those various special characters. The escape sequences, the \ with either tabs or new lines, and then, quotes. Yeah, you're right. And then the line 5 uses the verbatim string literal, which is pretty awesome. So what's this one saying now? The Unicode escape characters. This is where things get really interesting.
Okay, so what in the wide world of sports is this?
So yeah, you can also add encoded characters and literal strings by using Unicode. So
Konnichiwa world, huh?
Yeah, Konnichiwa world.
Look at that. So we're not limited to like just the US English character set.
Correct. Right. So inside a string literal, you can escape with Unicode characters. You can use UTF-16, and there's many different other character sets that are available to you to use. All right, format outputs using Unicode escape characters. Now these I admittedly am less familiar with. It's not something I use very common in practice, but it's good to learn and recap here for an educational standpoint. So to generate Japanese invoices, ta-da.
Cool. Okay, so they've got a whole what's up there? Generate invoices for customer in English, and then it does down at the bottom this text in Japanese.
Absolutely.
So I have a question.
Mm-hmm.
And can I use like, so if we're talking Unicode characters, can I use just like non-standard English characters inside a string, like non-English characters inside a string, like say, emojis or other symbols?
Yeah. So if you just do right line and you do a string, you want to do a laughing emoji, totally fine. It
Has
has
to
to
be a
be a
string.
string. Yep. And then you semicolon and run it.
Yeah,
Ta-da.
look at that. Now, I do this technique. I use emojis and other. There's a whole bunch of useful characters that are part of the character set in Windows. Like for example, mathematical symbols like the degree
Yep.
symbol and the copyright symbol, euro, delta.
Well, real quick helper point here, though, for people who might be curious. How exactly are you opening this little dialog window, Cam, in your Windows machine?
So on Windows, if you want this little dialogue with all these special characters and emojis, and there's even a GIF picker in there. That's right, I said GIF, not
GIF.
GIF,
Yep. It's totally
because
GIF.
it's not a graphics interchange format. Um, if
And
you want this dialogue, you just hold the Windows key and press period. So Windows period. And then you have this handy little dialogue.
love it. Love it. That's
So so
magical.
so there's all these different characters that you can use inside a string. Now, it's legal. I say legal. It's perfectly acceptable in C#, but we actually don't advise it because a lot of IDEs, a lot of the editors that developers use to edit code, they don't support it. So they'll see that and they'll freak out. They won't work right, or various bad things will happen. So generally, it's not real acceptable to put those kinds of characters directly in code, directly in strings. You should tend to use the Unicode escape sequences like we showed you earlier, like
Mhm.
what we did with the Japanese characters. But there's beyond the IDE, there's really no reason not to do it.
Awesome. So let's continue on. We saw that output already, I believe.
Yeah, we did. All right.
So
So
to recap,
yep.
did you want to recap or do you want me to?
No, you recap. I'm going to zoom in.
So use character escape sequences when you need to insert a special character into a string literal, like \tab or new line \n, or a double quotation mark, which is / double quotes. Use an escape character for the / when you need a / to output. You do double /, so you escape it, and then / again, and that will represent a single / in your string. You can use the @ directive to create a verbatim string literal, and that keeps all of the white space and formatting and / characters in the string. You can use the \u plus the 4-character code to represent Unicode characters, UTF-16 in a string. And then Unicode characters may not print correctly depending on the application, and that's good to point out.
And that's kind of the same thing I was talking about with the IDEs not always supporting Unicode characters.
Well, and that I think is specifically talking about how sometimes council output, depending on the output character set. Yeah.
Mhm.
All
All
right.
right.
Let's see how we're doing here. So, we got to do string concatenation. All right. So let's concatenate a few things together. So string concatenation is the act of taking two strings, well, it's not even limited to strings, but it's essentially taking, in this case, for simplicity, two strings and conjoining them together or concatenating them. So we've got string first name equals Bob, and then we've got a string message equals Bob space plus the first name. So plus is the operator that's going to be used, and that signifies string concatenation. So the resulting variable value for message should be hello space Bob when you run it.
All right. So let me review the code before we run it just to make sure I got it.
Mhm.
So we have a string literal Bob
Mhm.
that we're assigning to this variable first name.
Yeah.
Then we've got another variable we're declaring string message, and we're assigning a value to it that is a string literal hello concatenated with that string variable first name.
Mhm. Absolutely.
Okay, look at that.
It says hello Bob. Awesome.
Perfect.
Pretty easy, right? Pretty straightforward.
Okay, so what's next?
So concatenate multiple values. So this is just taking different variables together and conjoining them all with multiple concatenation. So this is saying the message is equal to the greeting, which is hello, plus a space, plus the first name, plus exclamation mark.
So I have a feeling, because I'm skipping ahead in the text,
Yeah,
that this is maybe not the most efficient way of going about it.
it's definitely not. Yeah. But for exemplary reasons, it's kind of
And they simplify it first with, whoops, I hit the wrong key combination. They
with,
simplify it first with just, instead of having a string message that they
right
put the
output.
value into, and
Yep.
then do a console.writeline message. They just have the concatenation happen inside the console.writeline parameters.
Correct. Yeah. So that entire thing will be evaluated as a string. There's no need to declare a message variable and save it.
Perfect.
So to recap, string concatenation allows you to combine smaller literals and variable strings into a single string.
Cool.
And you can avoid creating intermediate variables that aren't needed, like message. Absolutely.
Awesome.
So string interpolation is essentially string concatenation, but on steroids. It's so much easier and concise, and many other programming languages have this concept of interpolation as well. So if we were to look at the first example where we were saying string message equals greeting plus, the space plus the first name, you can actually template that out using string interpolation. And you do that by saying, message equals, instead of starting with an at, that's for verbatims, you start with the $ before you do your double quote. So the $ says that inside this string, I can interpolate values and other variables and things of that nature. So we can say the greeting goes here and the first name goes here. So when we write this out, it will be, hello, Bob.
Perfect. Well, that's so much easier. That is so much easier to read and easier to write.
And then you can use string interpolation to combine literal strings with variable values. So just like,
so we can even condense it a little bit more, huh?
yeah. So if you were to, so just get rid of like the greeting, for example. Oh, there you go. Yeah, you can do it that way. That's fine. And then greeting, because message is no longer there. You can say message. Yep. So the first name variable Bob, hello Bob. So hello is part of your template. It's part of the string. And then we're interpolating the variable value that we retrieve from the first name variable. So then in this case, we can do things that are beyond strings. So for example, we can say version, which is an integer. So it's a number. Version 11, update text, update to Windows. And then we say the message is going to be interpolated as update text space version. And that says update to Windows 11.
Got it.
And if you're on Windows 10 or earlier, update to Windows 11.
So when we're using string interpolation like this, and we use a non-string, we're passing in a non-string variable or literal, it converts it to a string.
Absolutely.
Okay.
Yep. So one thing to note about C# is everything's an object. So real quick, for the point of explaining this, if you're on the version towards the end of line number 3, where your cursor is, and you say dot, we can actually access various things on this object. So we can say toString, which is a method, and you'll need parentheses. So that's saying take the version, call toString on it. Inside string interpolation, that happens implicitly for you on your behalf. So you don't need to call toString. Anything that's not already a string type will be, have toString called on it.
Cool. And then I see the next example does kind of the same thing that we did earlier, where we just avoid a line of code by passing the interpolated string directly into console.writeline.
Yep. And then you run it, and then you get the same result. And then we avoid, declaring something that was unnecessary. You can also combine verbatim literals and string interpolation. This is where things get really fun. So you have both the dollar and the @ sign. So we can have, no need to escape our backslash for our directory. And then we can also interpolate the project name within there, and that works beautifully.
So I saw a question. No need to add the .toString method. That is correct. We don't need to add the .toString. That's like David said. That's handled implicitly.
Yep, and that's that's for anything that you do inside of string interpolation. Any variable access, it will implicitly call toString for you, so you don't need to. All right. So to recap, we talked about string interpolation and how it provides an improvement over string concatenation by reducing the number of characters required in some situations. You can also combine string interpolation and verbatim literals by combining the symbols for each and using that as a prefix for string templating.
Cool. So we're coming up on our time box, David.
We are.
I guess we have a choice. Do we want to try to work through this challenge next, or do we want to fly through the next module? I think we could probably go with the challenge. I think folks are getting the flow of things.
Yeah, absolutely.
And I think we can, if so, in the description for this video, there should be the link to this learning path, right? This write your first code using C#.
Yep.
We've walked through this first module, the second module, and we're about to finish the third module.
Yep.
Now, as a reader, as an exercise to you, the viewer, we're leaving parts 4, 5, and 6 to finish this learning path.
And to be clear, I mean, we've spent, about 80 minutes thus far going through this. Each of these modules that we've worked through were anywhere from 45 minutes to, 55 minutes individually. So we are going through them rather quickly. There is more text and there are more little nuances and things that you can do as a learner to experience and toy with inside the, .NET editor within the browser to learn from. So I highly encourage that you continue leveraging that training. And let's go with the challenge now. So the challenge is to format and display instructions. So,
all right. So we're supposed to put this line of code in, these two lines of code in, project name and the message in Russian. So what are we trying to do here? We are in this challenge, print instructions to the end user to let them know where the application will output data files. Use only console.write line. What am I writing out here? I'm not sure what I'm writing out. Oh, okay.
So that's where.
Okay, so we've got this file path here.
Yep.
So all right. So I'm gonna guess that it's gonna be something like here, console.write line.
What if we just okay?
Just what?
No, I was just gonna say that. Oh, I see what they're doing. Okay.
Yeah. So we're supposed to get this output here.
Yep.
I'm using the variables that we declare to create that output. So view English output. So that's a write line, and then I'm also going to do a console.write line.
Yep.
I wonder what I could do here. Let's use.
It looks like a tab.
Maybe. Oh, there is a tab there. I know what character to use for. I'm going to do double quotes for a string, and I'm going to do a \T for a tab.
Yep.
And then let's go ahead and C:\\. I'm going to do a double \/ to escape it, right? Exercise, and then another double \. Then we're going to concatenate the project
name. Okay, I see where you're going with this. All right.
And then another string that starts off with an escape \, data.txt, and then semicolon. So let's see where we've got so far.
Yep. That looks
all right. So we've got the English output.
That looks good.
All right. So now let's try the Russian output.
So it
To,
says the next thing is, yeah, the Russian message, which fortunately they provided for us as a variable. So we should be able to access that.
yep.
I like
So
what you did on line 7. I just want to call attention to that real quick. So in lines 5 through 6, we're passing in string values. In line 7, we're calling console.writeLine, and then it's open and close parens, and it's terminated by the semicolon. We don't have to pass anything in this situation. That means that console write line has various method overloads that allow us to call it without passing anything to it. So that will just literally write a new line.
and then this one, I'm going to do a little bit differently.
Let's use, how about we use like a verbatim string literal?
Well,
so at dollar double quotes.
Dollar double quotes. How do we do a tab character inside a, I guess
4 characters, 4 space.
I just hit the tab character. So
oh, there you go. There you go.
Give it the path. See exercise. Where was I? Project name.
I think the dollar needs to come before the at.
Oh, does it? Yep, I think you're right.
There we go.
There we go. Project name. Now we're getting our syntax highlighting. Then the Russian culture scripter and data.txt.
Ta-da!
Right. Think that's going to run?
Let's do it. I think so.
Success.
Looks great. That looks. I think we satisfied that challenge. Awesome.
And they give solutions. Very, of course, again, like we said earlier, in C#, there are literally thousands of ways to do everything. So.
Yeah. Awesome. Let's do.
All right, let's run through this knowledge check and then wrap it up, my friend.
Awesome. So what are the following escape sequences should be used to add double quotes to a literal string in C# code?
Well, we just did that one.
We did.
Backslash double quote.
Perfect. So which of the following lines of code correctly uses string interpolation, assuming that the variable value is a string?
So
console.writeLine at.
Yeah, that one's not going to work. That's the literal, so that's not going to do anything with those. I mean, it's actually going to print the curly braces and value.
Right. Yeah. So the leading at is for verbatim literals. Right.
Yeah. So the first one and the third one, neither one of those are correct because of that.
Right.
But we can just, by process of elimination, realize that it's this one.
Yep.
Cool.
And then Unicode characters were embedded in the C# strings for the console application to present a greeting message in Thai. However, the message is only displayed as question mark characters. What is the possible cause? So there's a missing \u escape sequence for Unicode characters. The wrong Unicode characters were used, or the user's console doesn't support Unicode characters. And this is kind of what I elaborated on a little bit earlier. How about consoles not supporting the right character sets? So which of the following lines of code append a single backslash to the string directory?
Well, if I remember right, backslash is a special character inside a string, and it has to be escaped unless it's a verbatim literal. Is that correct, David?
Correct.
So it would be this last one.
Yes.
All right. So let's check the answers.
Ta-da! Awesome. And it's right at our time box. So this has been great. I think we could stop sharing now, and we'll start closing out. Yeah, this has been great. This has been a lot of fun. Hopefully all of our live viewers around the world have enjoyed this. We really appreciate your participation and engagement, your questions. Keep the questions coming. We'll continue to monitor follow-ups, once this is out on YouTube and things like that. As always, thank you for watching, and Let's continue learning C#.
See you around.